All right. So, as promised, this is for the advanced EMT. Our last chapter was chapter 12, medication administration. And I said I was going to do a separate video with some simple drug calculations. And that's where we're going from here. Okay. And I just want to give it a disclaimer that I didn't create all these slides, I did get some of them from online. Uh, so, the overview, we're going to talk about some abbreviations quickly. We'll talk about metric conversions, desired doses, concentrations, drip rates, and the medication. So CC would be cubic centimeters. DD is desired dose. GM is gram. GTT or GTTS would be drop or drops. IM is intermuscular. IO is interosity. IV is intravenous, and IVP is intravenous push. KG with a capital K is kilograms. Capital L means liter. MCG is micrograms. M capital EQ is mil equivalent. Mil equivalent. Some drugs are dosed with mil equivalents. MG would be milligrams. M with a large L is milliliters. Um, so microgram is could be mg with a special M, so you don't confuse it with milligram. And the micro drop is the special M with GTT. Okay, conversion. We're going to convert kilograms to grams to micrograms. Sorry, milligrams to micrograms. And then we'll convert pounds to kilograms and liters to milliliters. So we're converting weights or kilograms. We're going to convert it from a larger value to a small. We'll just move the decimal point 3 places. And vice versa, going larger. If it's a smaller value to a large, we're going to move it to the left. So example here, they have 3 kilograms. And in order to get that grams, that's one conversion smaller. So we're going to move the decimal point over 3 points or 3 spots. So 3 kilograms would equal 3,000 grams. Now to go from kilograms to milligrams, that's 2 conversions. So we'd have to move it over 6 spots. So we're talking about 3 million milligrams and 3 micrograms. I'm sorry, 3 million milligrams and 3 kilograms. Now the same conversion for micrograms, that's 3 conversions. We have to go to grams, we have to go to milligrams, and then micrograms. So we're going to have to move that over 9 places, which would be 3 billion micrograms and 3 kilograms. Pounds to kilograms, you divide the pounds by 2.2. That'll give you an actual kilogram. Or they have on here the 3 a.m. rule, which you take the weight, divide it by 2, and then minus 10%. So 10% of whatever after you divided the pounds, right? So, for example, let's just do simple math. We all know that 220 pounds equals 100 kilograms. So if you do this conversion, 220 divided by 2 is 110 minus 10% of 110 is 11. So roughly about 99 or 100. Therefore, if you need to convert kilograms to pound, you just do it in reverse order. A liter to milliliters, again, it's just like kilograms. We're going to move, if we're going from large to small, we're going to move it over 3 spots and to the right. And if we're going from small to large, we're going to move it over 3 spots to the left. So 1 liter would be for milliliters, it would be 1 conversion, so it'd be 1,000 milliliters. If we had 500 ml, if we wanted to figure out the liters, you're going to move that over 3 spots, so it'd be 0.5 liters or 0.5 liters. They go through all these conversions. I'm not going to go through them. Right? We've already went through all these, so it's kind of fresh. So milliliters versus cc's are the same value. So therefore, 1 ml equals 1 cc. So again, 500 ml would be 500 cc. 0.5 cc's is 0.5 ml. Or 400 cc's equals 400 ml. A desired dose is the amount of a particular medication to be administered. This is our dose. This is what we want. The symbol / stands for per. So like 5 milligrams per kilogram per minute. A patient with chest pain needs 4 milligrams of morphine sulfate for chest pain, so 4 milligrams would be the desired dose. Hypertensive patient needs to be given dopamine at 10 uh, milligrams per kilogram per minute. The patient is 220 pounds. So first we have to convert our pounds to kilograms, which this would be 100. So it'd be 10 times 100 and divide that by 60. That would give us 1,000 or per minute, right? Kilograms. Yeah. So it'd be 100. So it'd be 1,000, right? 10 times 100 is 1,000. So 1,000 milligrams would be our desired dose. A physician orders 25 milligrams of Benadryl to the patient with itching and hives. Benadryl is supplied in a concentration of 50 milligrams per 2 cc. What's the desired dose? Our desired dose, I know they threw a lot of stuff in there, but he ordered 25 milligrams. So our desired dose is going to be 25 milligrams. We'll talk about the conversion here in a little bit. Patient with hypertension is ordered dopamine of 5 milligrams per kilogram and 275. Your dopamine is mixed at 800. So what's the desired dose? They say 625. Let's try to figure that out. First of all, you can convert the kilograms to or pounds to kilogram. So it's going to be 275 divided by 2.2, and the actual is 125 kilograms. Or you can use the 3 a.m. method, which would be the 275 divided by 2 minus 10%, which would be 138 minus 13, which would be 25 kilograms. So ordered is 5 milligrams per kilogram. So 5 milligrams times 125 kilograms equals to 625 milligrams a minute that they showed you earlier. Pediatric patient received atropine of 0.2 milligrams per kilogram. The patient is 18 kilograms. What's your dose? So here, if you're in class, I would pause this video or I would make them figure it out. But since we're not in class, we're going to take the 0.2 times the 18, which is going to be what, 0.36 milligrams. 0.36 milligrams or 0.36 milligrams is our desired dose. Now let's talk about concentrations. This is the concentrations found by dividing the weight by the volume. So example, 50 milligrams in 2 mLs. And the answer will result in that concentration. So in that, it would be 25 milligrams per ml, right? So we divide that by that. So Finnegan is ordered 12.5 milligrams. It's applied in 25 by 2. So what would be your concentration? So take a moment, pause the video, figure it out, and come back. And so the answer would be 12.5 milligrams in ml. So we're just dividing the 25 milligrams by the 2. Lidocaine ordered 2 milligrams a minute. It's applied 25 grams per milliliter. What's the concentration? Again, pause the video and figure this out. Okay, so the answer is 0.4 grams or 4 milligrams per minute. So what they do here is you have to convert these grams to milligrams. So we know that there are 1,000 milligrams per gram. So it's going to be, there's 2 of them, right? So it's 4, that'd be 4,000 divided by 500. That's where they come up with the 4 milligrams per milliliter. Or if you don't convert it, it'll be the 0.4 grams. You divide 2 by 500, it's 0.4 grams. But it's just easier to convert that to the dose that you want. Morphine ordered 5 milligrams, applied in 10 milligrams in 4 milliliters. What's your concentration? Again, pause the video and I'll give you a second. It's 2.5 milligrams per milliliter. Pretty easy, right? 10 divided by 4. Give you 2.5 milligrams. That's our concentration. They're not wanting to know how many you're going to need, right? So you're going to need 2 milliliters, right, to make that 5 milligrams. Diazepam is ordered 5 milligrams, applied in 10 milligrams per 2. So what's your concentration? So go ahead and pause, figure that out. be 0.5 milligrams per milliliter, right? So there's point or the five. I'm sorry, 5 milligrams per milliliter. So you divide the 10 by the 2. So your actual, uh, you're going to give 5 milligrams. You're going to have to give 1 ml. Dopamine ordered 5 micrograms per kilogram a minute. Patient's 210 pounds. It's applied 800 milligram per 500 ml. What's the concentration? Again, it's going to be 1600 micrograms or 1.6 milligrams. I'm dividing that by that, 800 micrograms. So what's going to be our concentration? Again, take a moment, pause the video. When you get it, come back. Okay, did you get, oh, no, I'm sorry. That was the answer. That is the micrograms, right? They're wanting the concentration. They didn't want the dose. I'm sorry, I messed up right there. Okay, so calculating the ml to be given is very simple. The D divided by H times Q. So D stands for dose. This is what we want to give. So the micrograms, milligrams, micrograms. The H is what we have or you're supplied in. And the Q is quantity. Does it come in, right? So Pentagon is ordered in 12.5 milligrams. It is supplied in 25 milligrams per 2 ml. How many ml are you going to give, right? So first of all, we're going to have to convert this to ml, and then we need to figure out how many we're going to get. So we're going to give them, we're going to do 12.5 milligrams divided by 25 milligrams, right? That's our dosage, times 2 ml. 0.5, or it's 1 ml, right? There's an easier conversion of this. I would just convert this first, right? That there is 12.5 and 1 ml. So I need to give 12.5. So I would just give 1 ml. That's an easier conversion. Adenosine is ordered 12 milligrams IV push after no response to 6 milligrams. Adenosine is supplied in 12 milligrams per 4 milliliters. How many milliliters are we going to need to give? Pause it, figure it out, come back. I'll give you a second. Okay, did you get it? 4 milliliters, right? So we need to give 12, and that's what we have. Well, that's our order is 12, and our concentration is 12 and 4 ml. So we're going to give the whole 4 ml. Lidocaine is ordered 1 milligram per kilogram to a patient that weighs 150 pounds. I've done the conversion for you at 68 kilograms. It is supplied in 100 milligrams per 5 milliliters, or it'd be 20 milligrams per milliliter. I've done that conversion. So how many milliliters are you going to need to give? Take a moment, pause the video, come back when you have your answer, and compare it to what I'll give you. Okay, we're back. So here we go. It's 3.4 milligrams, right? So we're dividing the 68 or kilograms, or we're giving 1 milligram per kilogram. So we need to give 68 milligrams, right, for our formula. And we're going to divide that by 68 by 20, which gives 3.4 mLs. Amiodarone is located or ordered at 150 microgram IV push over 10 minutes. It's supplied 200 milligrams over 10 ml. How many mLs are you going to give? Go ahead and pause, figure out the conversion, pause this video, come back, see if you can compare it to my answer. All right, did you get it? 7.5, right? So how are we going to figure this? Well, we need to figure out how many we're going to have in each ml. So you're going to divide 200 by 10, right? So we're going to have 20. So then we need 20 in each ml, but I need 150. So I'm going to divide that 20 by 150, or 150 by 20, give me that 7.5 ml. Making sense? Lasix is ordered 40 milligram IV push. If it's supplied 100 milligrams per 3 ml, how many ml would I need to give? So again, first we're going to have to convert this into per ml and then divide that into 40, or 40 by that. So the answer is going to be, I'll give you a moment, pause the video. When you get it figured out, come back. Okay, did you get 1.2, right? So 100 milligrams divided by 3 mLs, that's going to be 33 roughly. 40 divided by 33 is roughly 1.2 mLs. Epinephrine is 0.3 milligrams, 1 to 1,000 sub Q, is ordered to a patient with anaphylaxis. If it's supplied 1 milligram per 1 milliliter, how many mLs, right? So this one's pretty easy because we have the 1-to-1 conversion, right? So we're going to go ahead and give 0.3 milliliters because you got that 1-to-1 conversion. We don't have to convert anything. It's already at that 1 milligram or milliliter. And I know I need 0.3 milligrams. And if I have 1 milligram and 1 milliliter, I'm going to need 0.3 milliliters. Epinephrine, 0.3 milligrams at 1 to 10,000. IV push is ordered for pediatric patient. If it's supplied 1 milligram and 10 mLs, how many mLs am I going to need, right? So pause the video. When you get it figured out, come back. So we're going to give 3 mLs, right? So how did I figure that? We're going to divide 10 or 1 by 10, right? So let's do this together. We're going to divide 1 divided by 10 equals 0.1. So I got 0.1 ml or milligrams in each ml, and I need 0.3. So I want to take that 0.1 times 0.3, it's going to give me 3, right? 3 ml. Or, sorry, times, so I got 0.1, so multiply that by the the 0.3, which will give me 3 mLs. Drip rates. This is saying, remember that you have to, if you're going to mix medications into fluid, you have to withdraw the amount of fluid from the IV bag and replace it in the medication. So, for example, if lidocaine comes 1 gram and 25 ml, you would mix 1 gram in your 500 ml bag. First, you want to withdraw the 25 ml fluid from your IV bag, then replace it with the 25 milliliter containing the lidocaine. So if our lidocaine comes supplied in 25 mLs, gives us 1 milligram. And we're going to mix 1 gram into 500. So that's how we're going to mix it. We want 1 gram of the lidocaine in 500 ml. We know that there's 1 gram of lidocaine in 25 ml. We're going to remove the 25 ml from the original bag, right? Get rid of it, and then inject the 25 ml with 1 milligram in there, and then we'll be back to that 500 ml. If not, we'd be in the 525 because we just added 25 from that to the 500 bag. So to figure drip rates, we're going to figure the ml times the drip factor times the minute, or divided by the minute. Example, 500 ml using 15 drops at over 1 hour. We take 500 times 15 and divide that by 60. That'll give us 125 drops a minute. So let's look at that again. Milliliters times drip factor divided by time in minutes. So 1 hour is 60, right? So 500, the example of 500 mLs over 1 hour, 500 times our 15 or drops or drop factor, and we're going to divide that by 60 minutes, 1 hour. That gives us 125. Physician ordered 500 ml or 500 ml LR to be infused over 2 hours. You have a 15 drop tubing, IV tubing set. How many drops per minute would you give? Pause the video, use that formula I just gave you, and get it figured out. When you get it done, just go ahead and come back. 63 drops a minute. So how'd they figure that? They took the 500 times the 50 and they divided by 120, which will end up giving you 63 drops a minute. So that's going to be what, one drop, just under a second. You order 200 ml of 9.9% sodium chloride, and it's to be infused over 1 hour. You have 10 drop IV drip set. How many drops a minute would you give? Go ahead again, pause the video, use that formula, and figure it out. When you get it figured out, go ahead and continue the video. 33 drops a minute. So how did they get that? Right? So they took the 200, the ordered dose, times 10, right? And then they had to divide it by 60 because it's 1 hour. So 200 times 10 is 2,000 divided by 60, 33 drops a minute. You got an order for LR to be given KVO or 30 ml an hour. You're using 15 drops. How many drops a minute, right? So let's figure this out together. You're going to take your 30 ml, that's your order, times 15, divide by 60, right? So you're going to take your 30 times 15 is 450, and divide that by 60, should give us about 7.5 or 8 drops. 8 drops a minute, right? So we're going to round up, so it's going to be 8 drops a minute. You start an IV of normal saline, and a physician requests that you give 150 ml an hour. You're using 15 drop set. How many drops a minute? Again, it would be 150 times, wait a minute, it'd be 150 times 15, and he wants it over an hour, so you can divide that by 60, right? And that should give us 38 drops a minute. Because if you use a calculator like I just did, we end up at 37.5. So we're gonna round that up to 38 drops a minute. A patient that you have established an IV on is receiving LR KBO at 30 a minute. You have 60 drop tubing this time. So how many drops a minute are you going to give? So again, we're going to use that formula. We're going to take our milliliters times our drop set. So that's going to be 30 times 60. And then we're going to divide it by our minutes, which would be 60. So that's going to give us what? 30 drops a minute. Now, I will tell you that when you have a 60 set drop set and you have 1 hour, that will cancel itself out. So it's pretty much the ml, right? But you can still use that formula. It'll still work. We're going to talk about dopamine. It's a weight-based drug, so they want you to figure weight-based calculations. Dopamine, we use 60 drop tubing. And for the conversions, to make it easy, most of the time it's supplied in 1,600 micrograms per milliliter. You're going to see the dosage of like 800 and 500 ml or 400 and 250. That's still going to convert to 1,600. So you take the micrograms times kilograms divided by 25. Patient that is impaired in renal function receive 2 micrograms per kilograms a minute. You have 800 microgram of dopamine in 500 milliliter IV bag of normal saline. You have 60 set drop tubing. Patient weighs 250 pounds, which I've converted down to 114 kilograms for you. How many drops? You see it already says 9. So how are we going to figure that? We're going to take 2 micrograms times the kilograms, which is wait a second here. What are we doing here? We're going 2 times 114. Then we're going to times our drop set, which would be 60. And then we're going to, I'm sorry, I forgot where is that? IV set. So that gives us, and then we're going to divide that by our concentration, which in this case is going to be 1,600. which gives us an 8.55 or 9 drops a minute, right? Because we know this concentration, 800 milligrams. So if we convert this to kilograms, or micrograms, that would be 800,000 divided by 5. That would give us 1,600. So we have to divide. So we take our desired dose, right? So it'd be our 2 micrograms times our kilograms, 114, times 60, our drip set, our tubing, and then we're going to divide that by our concentration, which is 1,600 micrograms, and that gives us 9 drops a minute. Patient in bradycardia to receive 5 micrograms per kilogram a minute. Your premix is 1,600 micrograms, 60 set of drop tubing. Your patient weighs 175 pounds. How many drops per minute? The answer is already up here. I'm sorry, I apologize. So we're going to have to convert the weight first. So 175 divided by 2.2 equals 80, right? 79.54 or 80. So we have 5 times 80 times 60, or drop set, which is 24,000. And then we're going to divide that by our concentration of 1,600, which would give us 15 drops, right? So that's how we're doing all that. Everybody following me? I know this one's a little confusing. We start doing weight-based stuff, but it's not too bad. All right, so a hypertensive patient receives 10 micrograms or 10 micrograms per kilogram a minute of dopamine. You have 400 milligrams and 250 ml of normal saline with 60 drops set. Your patient weighs 220 pounds. How many drops a minute? So I'm going to give you a second to go to do the math on that, and I'll give you the answer. So pause the video, read through this again. And again, I told you earlier that if you notice the one that was 800 micrograms, 800 milligrams and 500, and now we got 400 micrograms and 250. That's still going to be 1,600 micrograms per milliliter, right? So remember your formula. 10 micrograms times your weight in kilograms times your drop set, which would be 60, divided by your concentration, which is 1,600 micrograms. So pause the video, figure it out, come back in a minute. Did you get the answer? It's 38 drops a minute, right? So let's go back and I'll help you, right? So first of all, we got to convert the weight, right? And I definitely know that 220 pounds is 100 kilograms. So you got 10 micrograms times 100 kilograms times 60 for our drop set, which is 60,000. And then we're going to divide that by 1,600, which would be 37.5, which will round that up to 38. Lidocaine. We can use the lidocaine clock, and I'll explain that a little bit. If we're using 60 drop tubing, and our supply or concentration is 4 milligrams per milliliter, which most of the time it is. So if we're ordered 4 milligrams, we're going to have 60 drops. We'll just start here. 1 milligram is going to be 15 drops a minute. 2 milligrams will be 30 drops a minute. 3 milligrams is going to be 45 drops a minute, and then 4 milligrams will be 60. So if we multiply our dose by 15, that's how many drops we're going to get, if that makes sense. So 1 times 15 is 15 drops. 2 times 15 is 30, so we'll have 30 drops. 3 times 15 is 45, so we'll have 45 drops. And then 4 times 15 is 60. This is if we're using a concentration of 4 milligrams per milliliter and using 60 drop tubing. So with that formula, we could do the math, right? You can do the math and you'll get the same answer, and I'll show you that here in a second, or I'll explain it here in a second. Or you can use the clock, right? If we know everything's working. Patient with multiple PVCs received 2 milligrams per minute of lidocaine. You have 1 gram and a 250 ml bag of normal saline along with 60 drop tubing. So we have the 60 drop tubing So we're going to convert the 1 gram to milligrams, which would be 1,000, and divide that by 250 would be 4. So we do have the 4 milligrams per milliliter, so we can use the clock method, right? So 2 times 15 would be 30, right? So our answer is 30 drops a minute. So is the way we do that. So you can use the conversion set too. Let's go back to do the formula, like I said. So first of all, like I said, you're going to have to convert the 1 grams to micrograms. So we got that. So that's going to be 4, right? So our concentration is going to be 4 micrograms. So we're going to take, and we're ordered 2. So 2 times 60, our drop set, is 120 divided by 4 equals 30 micrograms. So you can use the long formula and it will work. So after successfully resuscitating a patient in VTAC, you're ordered to start a lidocaine drip at 3 milligrams per minute. Your premix lidocaine package is 2 grams and 500 milliliter. You also have 60 drops tubing. So how many drops a minute will you give? Go ahead and pause the video for a second, figure it out, and then come back. All right, so the answer is 45 drops. So first of all, we're going to have to convert our concentration to milligrams, right? So we have 2,000 milligrams, because 2 times 1,000 is 2,000. We're going to divide that by 500. That gives us our 4 milligrams per milliliter. So we can go back and use that clock method. So 3 times 15 is 45. Or you can do the formula as well, right? So you have 3 times 60 equals 180 divided by 4 equals 45, right? So our ordered dose times our drop set, which would be 60. Ordered dose is 3 milligrams times our drop set, which is 60, divided by our concentration, which would be 4 milligrams in milliliter, in 1 milliliter. So that would give us 45 drops a minute. This making sense? Patients to receive 4 milligrams a minute of lidocaine. Your lidocaine concentration is 4 grams in 1,000. At 60 drop tubing, how many drops will you give? Right? So instantly we need to convert to milligrams because that's what we're ordered. So 4 grams is 4,000 milligrams. Divide that by 1,000. So that means we have that 4 milligrams per milliliter. And we're using 60 drops. So we can go ahead and use the clock method again. So 4 times 15 would be 60 drops. Or we could use the math as well. 4 times our 60 drop set is going to be 4 times 60 is 240, and then we're going to divide it again by 40, which would be 60, right? 60 drops a minute. All right, so that ends the calculation. It's pretty simple stuff. It's not as hard as what people thinks it is. So thanks for tuning in, and the next time I see you, we'll be talking about chapter 13.